Now, this may be a long, dark and dangerous road, but what we need to do now is we need to get into pointers. Now we'll do an introductory lesson. Start first of all. I need to do a new project. Line tool, and these pointers. Okay, super. Let's have a look at the main program. So don't need any of that, don't need any of that. Let's get rid of most of this. Okay, I don't want to use standards, so I'll need to put using namespace standard. Lovely. Okay, first thing we need to do is I'm going to set up 3 different variables. So let's have an int, set it to 0. We'll set up a float, set it to 0.0, and we'll set up a double. Now we're going to be playing around with memory, and what I want you to think of computer memory of, I want you to think of it as being a huge tall column of Lego bricks. And when I declare an integer, I get a certain number of Lego bricks of memory to put that integer into. Think of these as being hollow Lego bricks. Now I'm going to get 4 or 8 or 2 or I don't know how many, because I haven't checked on this particular compiler, but I'll get a certain number of Lego bricks to put that int into. With a float, I'll get a certain number of Lego bricks in this huge column of Lego bricks, all of which are numbered sequentially, 1, 2, 3, 4, 5, 6, 7, all the way to 10 million. If you've got 10 megabytes, but in hexadecimal format, because the whole of computing is based on switches on or off, 0 off, 1 on. So because of that we use hexadecimal, which is 2 to the 4, I think, don't quote me on that. So an int will get 4 bytes or 2 bytes, a float will get 2 bytes or 4 bytes or 8 bytes, a double will get 4 bytes, 8 bytes, 16 bytes. Let's find out how many bytes each one of these things gets. So memory Lego bricks for an int. Special command called sizeof, which will tell us how big an int is. What was it putting down there for? Strange. Oh, I need to just make this bigger. There we are. Not big enough. And we need to just finish that off. Now, how many memory bricks does the float get? And how many Lego bricks of memory in this huge column from 1 to 10 million with a 10 megabyte memory does the double get? Let's check this variable, this double variable. There we are, that should do it. Now what doesn't it like in that first line? Oh, yes, of course. Yeah, let's make them line up, otherwise it'd be too ugly on the eye. So let's give that a run, see what we get. So the integer gets 4 bricks, the float gets 4 bricks of memory, and the double, 2 times the float, as the name would suggest, gets 8 Lego bricks. Now, what's the address of each of these Lego bricks? What I'd like to do now is find out where these Lego bricks have been assigned. That could be anywhere in the Lego brick column. What do you think? I want you to imagine a million Lego bricks piled high from the floor up to, 30,000 feet. And each one has a label on it. 1, 2, 3, 4, 5, 6, 7, 8 to 50 million or whatever it is. That label is in hexadecimal. So what I'd like to do now is I'd like to find out the address of each of these little areas. This gets 4 Lego bricks, but where are they? Where do they start? This gets 4 Lego bricks, but where are they? Where do they start? Could be anywhere in the column. This gets 8 Lego bricks, somewhere in the column. I want you to imagine 10 million blue Lego bricks. There's 4 red ones, 4 yellow ones, and 4 green ones. Somewhere in this column of millions and millions of blue Lego bricks. 8 of which, no, not 8, 16 of which have changed colour. Now before I do this, I need to do a couple of little things to see out so I can print out hexadecimal numbers. Just have to trust me on these 2 lines. I don't want decimal, I want hexadecimal. So there we are. Now I'll be able to print out the address of where each of these variables is living in this huge column of blue memory Lego bricks. Now we access that with a special symbol called the ampersand. Ampersand begins with an A stands for address. Think of it like that. So I want the address of the int variable. I think this is a number on a number on the side of a safety deposit box. Again, make them line up. Makes our life too difficult. Okay, so we're just going to print out the memory address, the sticky label that says where that int lives in this huge column of millions and millions of Lego bricks all piled up. Where are the 4 red ones? Where are the 4 green ones? Where are the 8 yellow ones inside this huge column of blue Lego bricks? Now will this work? Let's give it a go. Hooray! And there they are. That's where they start. The red yellow bricks for the int. There's 4 bytes. That starts at this place here. And we've got this place here. Now this is in hexadecimal. Now what I will do, just for you, just for today, is I will draw out a little map. We'll put it down here. And we'll do it as commented. It might get pretty big, so I'm going to break a few rules and stick it over here. So, the key thing here is the EC. Now let's do the letter before the E. That's going to be, what's that? What's the letter before E? D. 16 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then there's 16 E's. I think of 10. There's 10, 11, 12, 13, 14. There's 10 of those, isn't there? 0 to 9, 10 to 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. And then we'll do the ones afterwards as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's like the tens column in binary, in decimal, sorry. And then that's going to be, if this was 10, then that would be D0 would be 10. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then, because it's hexadecimal, A, B, C, D, E, F. Now let's copy those across. So there's the last 2 characters of my, see that one there, EC? Well, that's this one here, EC. That's where my integer starts. So my integer was that EC. EC starts there, and there's 4 bytes in my int. 1, 2, 3, 4. And what does it contain? That little block of memory contains a 0. We haven't printed it out, but I'm sure you can believe me that it contains a 0. Let's do the same then for the float. Let's put this down a bit. The float starts where? The float starts at E8. Okay, so that's here, E8, and it's 4 bytes long, so it's right next to it. Now it doesn't have to be right next to it. It's often right next to it because that's nice and clean, but it could have been anywhere. It could have been down here. It could have been, I mean, probably be typically more there. It could have been anywhere. It could have been miles away from this. The 4 red bricks could be at the top of the column, the millions of columns, and then the 4 green bricks could be at the bottom or the top or the middle. Now, typically they will be, especially when there's 4 and 4 making 8, they will be next to each other. And what does that little block of memory contain? It contains a 0.0. Okay, so it might be best if we just put some little markers in here to show a little bit more what's going on. So the float is contained in there, and the integer is contained in there, and it's 4 bytes long. Are you all with me so far? So the integer begins at EC. It's 4 bytes long, and it contains a 0. Let's just finish this off with a double, then we'll finish this lesson. We'll move on to real pointers in the next lesson. The double start at position 0. Notice they're being prepended. They're not appending to the integer, they're prepending. They're going before the integer. They're not going ahead after the integer. Again, it's all down to the compiler. This is starting at E0, which is here. It's 8 long. So 1, 2, 3, 4, 5, 6, 7, 8. Starting there. 1, 2, 3, 4, 5, 6, 7, 8. Let's just put some markers. Oh, let's put what's in there. It's a 0, 0, isn't it? So 0.0. And just to ease our eyes. Oh, by the way, these memory addresses will change probably every single time I run the program, so this could get a bit tedious typing out new letters. Hopefully they'll use the same patterns and the same numbers. So we've got 3 little blocks of memory. We've got the 4 red Lego bricks. Start here. Inside those 4 hollow red bricks there's a number, 0. The float starts here, E8. That little 4 block of yellow Lego bricks contains 0.0, hollow Lego bricks. And these 8 Lego bricks start at E0. 8 bytes is allocated, and currently those 8 bytes contain 0.0. I think that's probably as much as we can do now. We're going to cover 3 special variables in the next lesson called pointers, which are going to play around with various aspects of this memory construction. Look forward to it. It's going to be great.